thanks everybody for coming. It's good to see so many people actually. Thanks to Vicky for organising everything. She's done everything. I haven't been too busy on the boat, so it's all down to Vicky this, so Vicky's the one to thank. Right, so I'm going to take you through construction of one of the boats, and any questions at any time throughout, just let me know. Basically, building on what Alan said from Rochling and what Lewis was just talking about with the welding equipment and the materials, we have to use the best materials for the product. It's easy for us to go and buy material from India, from China, wherever, but what we don't know is what's gone into that material in the process. We don't know if we've got recycled product in there, we don't know if we've got all the same grade material in there, and we often find that you get umpteen emails every week from suppliers, we can supply you plastic at a cheap rate. We never go down that route because we can't guarantee the product, we can't guarantee the material. We know that everything that comes from Rochling and supplied by Amari is going to be first class, it's going to come with all the ISO standards, it comes fully accredited. The other thing that we get from Amari and Rochling as well is every single sheet that comes into the factory has its own identification number, and that gets logged into every single vessel. So in 10 years down the road, I know every sheet, if a client comes back and say, actually this sheet on this boat, something's happened to it, or it's discoloured, which is highly unlikely, I can go back and I can identify that exact sheet that's gone into that material, I can trace it back, and I can go and complain to Alan. In regards to the welding tools, the same process there. We use the best because we have to do that to get the equipment. And like Lewis was saying, with the welding nozzles that we use, you'll see this afternoon if you come to the factory, because our tools were on for 10 hours a day, 6 days a week, what we was finding was I think Lewis has got the gun over there, but the PTFE nozzle on the end was getting that hot with the gun being on. What was happening is the original ones were screwed on with a couple of screws, and the PTFE was expanding, and we'd be halfway through the day and the PTFE nozzle would come off. And the nozzles were quite expensive, and was buying new ones, and new ones. So working with Lewis, we decided, right, we're going to make our own. So we made one out of one solid piece of aluminium, and it worked absolutely fantastic. And like Lewis said, when we went back to Leicester and said, we've made this, what do you think? They said it won't work, but it did work, and then their revision of the tool virtually copied our design, although they still have a PTFE shoe on. So that's a little bit about our suppliers and the welding equipment. So to go through the workboat build, first, probably best to go through a little bit of background really. I left school at 16 and I lived at Paul, which is just down, for those of you who know this area, it's just a little village on the other side of Hull. Right across from my house was a shipyard. So before I'd done all my exams at school, I went across to the shipyard and arranged an apprenticeship for myself. So my background is a shipyard plater, and I did a full apprenticeship there before going on to other projects and moving out to Canada. I've worked in many industries as a surveyor and then building boats, but I've never done anything else but boats in my life, never done any other career. Part of the background when I was at Hepworth was we did everything was traditional there. We had a mould loft, so every vessel that we got, we'd get a set of plans. We used to actually get, rather than get drawings, we used to get a book of offsets. So we used to start in the mould off, big book of numbers for those of you who don't know what offsets are. It basically gives you a width and a height, and basically you plot all these dots on like a graph, and then you join all the dots in a line, and it gives you all the shapes of the frames. So we used to loft every single boat out in full scale. Then we used to pick the templates up, apply them to the material, to the steel, bend the frames, cut the steel, and we used to build fishing boats and tugs. We use the same process now, and although we design everything in AutoCAD and SolidWorks, they're no substitute for actually laying the vessel out on the floor to try it out. Because for all intent and purposes, that is as big as your screen is on your computer, and that's not the size of the boat. So your line on the computer might only be that big, and it looks perfect. But when you lay it out on the floor, you think, oh, there's a bit of a hump in that plate there, or there's a bit of an indent. So we can lay it all out, we fare it all out, and we've done that with every design that we've got. That process allows us to modify the boats and adapt them to the client's needs. So what we're able to do is we're able to take a existing design that we've got. This is for one of the rigid collared boats. So you can see on here, you can see the keel, and you can see the frames that have been cut on the CNC router. What we do with every single vessel that we build is we're always updating and adapting the drawings. And we work closely with the guys on the shop floor because they're the ones that are building it. So what we often find is we'll set these out, we'll set the frame out, and we might then come to put the shell plate on, and we think, oh, well, there's a bit of a gap there in that shell plate, nothing that can't be welded. But we'll take that and we'll adapt that into the next boat, into the next drawing. Or Marine Harvest, one of our biggest clients, they'll come and say, we want a little change here to the boat. If we think it's a really good idea, we'll adopt it into designs for the future. It might just be something that they need, which is bespoke to them. So we're always evolving the process and the design of the boats for different applications. On the design side, one of the key things that we do is we work very closely with the MCA. I worked with the MCA for many years on the workboat code and as a surveyor. So I know the ins and outs of how the MCA works and how the code of practice works for the design and the structural criteria for the boats. What we do is we take a base standard for everything that we do. So before we even start to build, we make sure that the boat's going to meet any criteria that's out there. As a base standard, we always take Category 2. For those of you that don't know, Category 2 is 60 miles from a safe haven, which then gives you a set wave height that the boat has to cope with, which then dictates the structural strength that the boat has to be. Once we've taken that, we then apply the rules. So for us, we always use DNV rules, or DNV-GL as it now is. So we use their construction standards. Now, it's a little bit strange for those of you that maybe know DNV and know construction rules. There are no rules for this material. They don't exist. It's not that the material hasn't been around for long enough. The material's been around for a long time, and there's been boats built from it from a long time. But there isn't enough boats out there for the classification societies to say we need a dedicated set of rules. So working with DNV, we've agreed a procedure where we build to the aluminium rules, and we apply a conversion factor for the material strength. So what we'll take is we'll take a standard aluminium boat of this size. We know the structural strength criteria, then we apply a conversion factor. And that conversion factor tells us how thick the material's got to be the equivalent strength of the aluminium or steel or GRP. Question we get asked by a lot of people when they come to us is it strong enough? Is it the equivalent strength of an aluminium boat? Well, it is, because we use the same rules. And because we use the same rules, it's the equivalent strength. What we say to clients as well is, although it's the equivalent strength, we actually put 10% on top. So we go 10% on top of DNV rules because the clients that we supply, like the fish farming, the aquaculture industry, a lot of commercial workboat operators, these boats get abused. I mean, they get run into piers, run into jetties, run aground, other boats dragged across, quite often they're loaded up to more than they're supposed to be. So we make sure that they're strong enough to cater for the application rather than just for the structural criteria that's needed. So once we've designed the boat, we'll then take into all the client's needs, we'll then go through the process of cutting it. So we put a frame file together, they'll all get nested into a sheet. We might use a sheet, say 3 meters by 2 meters. And to give you an example, for a 7.5 meter boat, one of the rigid collared boat, 3 sheets of material cuts every single frame in that, because we can nest it all in. So there's out of those 3 sheets, there's maybe less than 1% of wastage. So when it comes to the environmental and responsibility of the company, we're very keen on keeping the wastage down, not only because it costs us money with the scrap and we get nothing for the scrap. So we like to keep the amount of wastage down, so we nest everything into the sheets as far as possible. And we often find that we might have, we'll have all the frames for one boat out of one, and we might cut other components out of it, or might cut things for other applications out of the waste leftover sheet. So on here, what you can see is we use a flat sheet for all of the frames, the hull structure, and for everything. The only thing that we don't use a flat sheet for is the tubes. We don't have the capability to roll the tubes ourselves, or these tubes are actually extruded. So what we'll do is we'll buy the tubes in, Unfortunately, Alan doesn't supply tubes from Rochling, so the tubes come from their rival Simona. So we buy the tubes in 6 metre lengths, and we use various different size tubes. So you'll all notice on the boats, from the range of boats, you've got the RCB 300, 350, 400, 500, 600 and so on. That number relates to the diameter of the tube. So the RCB 500 is a 500mm diameter tube, and it has nothing to do with the overall size of the boat. So the boat can be anything. So we could have, Marine Harvest could come and say we want a 3 metre beam boat by 8 metres long. We could have Scottish Sea Farms come and say we want a 3.1 metre boat by 9 metres long. There's no problem. With the design programme, the way we do it, it's only a couple of days to change the design, to change all of the frames, to make the boat bespoke to your needs. So you can see, assembly-wise, I talked a little bit earlier about traditional shipbuilding, and that's how we build these. There's no moulding, there's no rotor moulding, which a lot of people expect with plastic. What we actually do is set it up as a standard boat build. So we lay the keel will get welded together, the keel then gets stood up on its end, and then we'll assemble the frame. So all the frames slot over the keel, which we call an egg box structure. So it basically all nests together without being welded. We also then cut, you can't really see on here, but the frames are all slotted for the longitudinal stiffening. All of that goes in before we shell the boat, as you can see there. So the frames are slotted over the keel, then it's all fully welded. So essentially, once that's all welded, as Lewis was saying, it becomes one piece of material. It's one structure. It's incredibly strong. The frame spacing on these boats is quite narrow, but we've actually extended that because we've changed the tool, like Lewis was saying, to the 3C, which is a much bigger gun. We have to allow for the guys to get in there and weld it, which is quite difficult, particularly when you're dealing with nearly 400 degrees of hot air coming out the end of the gun. You often hear a few screams where the guys have touched it on the ram when it's hot and things like that. So we have to be very careful on the design to make sure we can get access to the boat. So you can see one of the boats there. As we build the boat the right way up, we then put the tubes on. Once the tubes are on the boat and all tacked into position, we'll then turn it over. So once the boat's turned over, we'll put it onto some stands, and then we shell the boat before it's completely welded. The thing with the plastic, what you've got to be aware is, obviously, with it being plastic, there's a lot of movement in that boat. And it's amazing to see when you get it to this stage, how much movement and flexibility there is in that boat. And when you put the shell plates on, how rigid it becomes. It really is incredible. Being a boat builder all my life, I was amazed at the strength in these boats compared to a steel or an aluminium boat. As you can see on here, starting to put the shell plates on. Now, everything that we've done with the hull structure on these boats, we've enabled it to be cut by CNC. So essentially, for this 7.5 metre boat, we can cut absolutely every component for that boat in a couple of days. Because it's CNC cut, it's incredibly accurate. And as we've worked and progressed from boat to boat to boat, we've modified the design to make things more efficient, but also to make things easy for the guys that are assembling the vessels as well. So to get to that stage in the construction is about 1 week from start of assembly. So it's incredibly fast. To finish that boat, we're looking at, for the hull only, we're looking at 6 weeks. So compared to a traditional type build of a rib, aluminium or steel, or GRP, it's incredibly fast. So the shell plates all go on upside down, tacked from underneath. Once they're done, everything's then welded on the outside before the boat's then flipped back over. So we just use, because of the weight of the boats, we use a forklift. So at this stage, a 7.5 metre boat will weigh under a tonne, so about 800 kilos. So it's incredibly light. And depending on the material that it's made from, the ribs from Marine Harvest, for instance, they're all made from 15mm material. The requirement to the rules is only for 10mm. So because of the wear and abuse that Marine Harvest give the boats, we use 15mm for the hulls. Once the outside's welded and we turn the boat back over, what we then do is to add to the unsinkability of the boats, they're completely filled with polystyrene. So the entire hull structure, the entire length of those tubes is completely filled. The polystyrene we use is what they call C70. So the maximum water absorption of the polystyrene is 10%. So if you was to puncture the hull, you'd only absorb 10% of the volume, of the underdeck volume of that boat, which on one of these would equate to about 300 kilos. When you've got a positive buoyancy in that boat of over 7,000 kilos, you're pretty much guaranteed that unless you've got a hell of a lot of weight on the deck, the boat's going nowhere. And it was always a case with the MCA, those that know the MCA, your best life raft is your boat. You can see one of the examples of one of the boats there. This is one of the first ones that we produced in the factory here in Hull. This was actually a demo vessel for ourselves. This went off to Marine Harvest and still working successfully out there. This was designed to have twin outboards installed, but equally you could put inboard engines in there with water jets, stern drives, wheelhouse arrangement, however you wanted. But this was a 8.7 metre vessel. Again with this one, this is one of the later ones for Marine Harvest, and following on from what Alan was saying, with the Playtech we can engrave company logos, signage, so we've got, like you maybe can't read from there, but we've got a lifebuoy on there, bilge pumps. So it's very easy to make a boat bespoke to the client's needs. And also makes it readily identifiable for them as well, because they want a boat that everybody else is going to know that's Marine Harvest or that's Scottish Sea Farms, or with the Van Ord project, it's that company that we're dealing with. What we can also do with these is try and make everything out of plastic. We don't like to use, as far as practical, any metal at all in the vessels. There's two reasons for that. One is on the environmental side. Probably the main reason is corrosion factors, because aluminium's going to corrode, it's going to oxidize, it's not going to look very good. Same with steel. And on that side as well is the point that Alan touched on, is the thermal expansion of the steel and aluminium compared to the plastic is vastly different. To give you an example, the plastic we're looking at 2 millimeters per 10 degrees of temperature change. So on a vessel such as this, from 0 degrees at 7.5 meters long, it's going to grow by 2 millimeters for every meter in its length. So the boat that's going to Ghana, it'll leave here at 7.5 and it'll end up a little bit bigger in Africa, so they're getting more for the money as it gets out there. Contrary if you go into the Arctic. But so we try to keep everything in the plastic, and that keeps the thermal expansion all the same, so the boat's expanding and contracting together. So we don't use metal where we can avoid it. What you'll notice on here is we've got the mooring cleats, they're plastic, and they're 50 millimeters thick. And to give you an example of how tough these boats are, a vessel very similar to this, which is shown a little bit later on actually, the Black Pearl, we had these mooring cleats in, and Scottish Sea Farms, it goes out to a farm in Muck, which is off the west coast of Scotland in the middle of nowhere. And they have a big feed barge out there, which is 400 tons in weight, and it's anchored by about 12 anchors, so it's static, it's fixed, and the seas just go right through it. They had this, went out to the farm, pretty bad conditions, tied the boat up, and they're out there for about 10 hours feeding the cages. But while they was out there, the weather got even worse, and it was about a force 10. Big swells coming through the farm, and they tied the boat up to the farm really short, with short ropes. So as the waves are coming through, it was lifting the boat up, and as the wave passed, the boat was just suspended in midair on the ropes. And it was doing this all day. And they actually found that it actually ripped this cleat, it actually ripped it completely out. That cleat goes right through the tube and welded on the other side. And the welder, they'd actually ripped that entire thing out of the tube. It was unbelievable to see. But the boat was still afloat, no problems, no issues. They got back to shore at the end of the day, re-welded it in. No problem whatsoever. So it's incredibly strong, but even in conditions like that, it's amazing how I think an aluminium boat would probably be on the seafloor. A little bit of an example of this is an outboard powered boat. So we've got the transom well, see the tubes at the back. 2 outboards go on here. This will take 2 80 horsepower outboards on this vessel. That was an 8.5 meter vessel, that one. total weight finished on that boat was 1.2 tonnes. And with twin 80 outboards on there, and that's a 3-metre beam as well, with twin 80 horsepower outboards on there, that did 29 knots, which for a wet boat that size, for those engines, is absolutely incredible. A little bit of detail on interior layout. This was one of the first ones that we did, and you can see in here we've got a bit of aluminium checker plate. Ignore that, we don't do that anymore. But console layouts can be bespoke to the client's needs. That was just a small single-man wheelhouse. This was a black pearl that I was talking about, and these are the cleats that they've ripped out. But that was inboard diesel, Iveco engine with an Armar jet, water jet. Perfect boat for the fish farms with diesel engines. MCA clamping down now on a lot of marine use with outboard engines in the commercial sector. The fishing sector, you're not allowed to carry petrol at all below decks. So more and more things are moving away. The leisure industry is a big petrol user, but more and more in the commercial world, diesel engines are becoming the way to go and the way forward. The Carriage of Fuels is another issue as well for these boats. You see an example of the water jet there. The one in the factory's got a Hamilton water jet. Operates in exactly the same way, slightly different on the fitting and the design. Water jets are good for us. They're a nice, easy install. Easier than the conventional shaft and prop. The water jets give you excellent manoeuvrability, but the biggest bonus with the water jets is they're highly efficient at high speed, as opposed to any other type of propulsion. So in these applications for the rigid collared boats, which are often going pretty fast, some of the patrol boats that we've done and that we're currently contracted to do, some of those are in excess of 45 knots, which is quite a speed on water. Typical outboard installation, that's twin 150 horsepower Mercury's on there. That vessel was 40 knots on an 8.5 metre boat, both mounted to the transom well. And as I was saying before, with the design of the vessels, what we'll do is we'll look at the power that's been installed and modify the vessel to suit that power. Because obviously what you often find with a lot of manufacturers is they'll build a boat and it's a stock boat, it's a standard boat that goes out. And you might find that it's actually built to maybe take two 80 horsepower engines, and you see it quite a lot where you'll see this boat that was designed for twin 80s and it'll end up with twin 300s on the back or something like that, and the transom's just not strong enough and they give it full power and they wonder why the transom cracks. So we design everything to meet what the client wants. What we try and do with them is we try and work with them. We always like to try and meet with the client before we even start to design the vessel, simply because we want to know what they want to do with the boat in the future. They might not know it, but we can give them a pretty good idea of, you know, we think you can do this with the boat. Would you ever need to do this job? And what it allows us to do is it allows us to build in capacity in that vessel and future-proof it. So 9 times out of 10 with anybody that buys a boat, and I think it goes across all sectors, is they need a boat that's that big. And when they come to the factory and they see another boat that's that big, they say, that's the one that I want. And that's human nature, or maybe it's because most of the people that buy boats are men, I don't know, that they always want something bigger and better. But we try and work with the client to give them exactly what they need, but also to future-proof the boat as well, and give it the extra capability. You see inboard engine installation. That's a N60 Iveco 400 horsepower, coupled to the Almarin water jet, like I said. Quite a tight compartment to get in, but when you've only got a 7.5 metre boat, you don't want the whole boat to be engine. So we've got to keep things pretty tight. Same again, like I say, we can use the Playtech material for the signage, so company logos, the name of the vessel, you know, simple little things like, you know, life raft and safety signs, our logo on with the life ring holders. So we can pretty much design anything. Another example of the boat. You see there, obviously the water jet with it all running. That was actually a really nice boat, Marine Harvest. They actually damaged the engine on that boat, well, damaged the water jet actually. Their guys don't really respect the boats too much. I think I can probably say that quite safely. And it's a tool. The boat's a tool to do a job. And they actually went over a string of pots, crab pots, and they actually sucked up the rope, the anchor rope, and it had a big shackle on the end, and that went through the water jet and basically destroyed it. So at that point they were saying, we're not going to have a water jet boat anymore, we're going to sell that boat and we're going to go back to outboards. However, they replaced the jet. It was a brand new jet unit. They put one in it, they took it back out. The guys got severely told off, and now they love it and they're looking at some more. So it's the way to go. Black pearl, just looking for something. Oh. The look of the boat, like I said, with the plastics, there's many colours out there, so we can pretty much do anything we want in client colours. We can actually, if you've got a bespoke colour, Rochling will colour match it, providing you order a certain amount of material. So we can pretty much do anything you want in your corporate colours. The contract that we've got with Van Ord, one of the things that they've requested is they want a full repair kit supplying with the vessel. So because these vessels are going out to Kazakhstan, it's not as easy for us to go out there and effect any repairs if need be, or for them to bring the vessel back for repairs. So what we've agreed with them is we'll train a couple of their engineers on how to weld, on the equipment, on the material, and then they'll be able to effect their own repairs. We're going to supply them a welding gun with the vessels and some of the sheet material and the wire. The vessels themselves, the plastic itself is incredible, and for those of you that come around the factory this afternoon, you can actually have a go with a welding machine. It is incredibly simple to use and effect a repair. The beauty of this material for boat building is that because of the HDPE, the polymer structure, and the weight of the boat, what you actually find is if the boat actually hits something in the water, if it was an aluminium hulled vessel, you would hit something such as the corner of that laptop and it would deflect the bottom of the hull. If there was sufficient force there or impact there, it would stay permanently deflected. If it was something that was quite sharp and it got to its point, it reached its elastic limit on its deflection, you would then actually puncture the hull. And then you'd obviously have a flooded boat. What you find with the plastic is there is no, well, there is an elastic limit, but because the elastic limit is so big, what you'll find is the boat will actually ride over that and it'll deflect a lot more than the aluminium will. But the actual rate of deflection with the structure there, once that reaches the impact velocity of the boat and the actual, what am I looking for? The word I'm looking for. It equals the weight of the vessel. It'll then ride over it. And then the hull will come back. So what you find is with these boats, you can ground them out, you can run them up the beach. If you do hit a submerged object in the water, you will hit it and yeah, the boat will list over to one side while you go over it, but it will ride over that object rather than hit it, permanently damage the hull, deflect the hull or puncture the hull. And that's one of the beauties of this material. The repair side of it, like I was saying earlier to a question, is you can actually repair it with a soldering iron. All you need is something that's hot, about 200 degrees, and you can actually then start melting it in. So a soldering iron would work ideally to, to melt the hull back together, or even just weld a patch on with one of the hand tools that Lewis was talking about. Simple to use. Because we film with polystyrene, even if you ripped an entire hull plate off, it's not going to affect the vessel. It might be a lot slower, and you're not going to achieve planing speeds, but it's going to be a lot easier to use. Well, there's a hand tool that Lewis has brought, and you can see with that, basically all that does is puts out up to 500 degrees of air out of the nozzle at the end. Put a welding rod down there, and basically it's literally you just run along with that, and it lays a bead of weld. You don't even have to use a welding wire because you can just use the end that gets hot, and you just melt the two surfaces together, and that's your repair done. So it is very, very easy to repair.